Hello there. Welcome to another video in my series Matlab, the Basic Basics. This video is Making Matrices, Part 1, the very beginning of how to enter matrices into Matlab. Please note that the web page where you found this has many other videos in this series, and the links should all be there. So take a look at those when you have the chance. But for now, let's get down to basics. If I wish to enter a matrix into Matlab, it starts off very much like it would if you were to do it by hand. Place a square bracket, and then simply type in the numbers of the first row separated by commas. Say 1, 2, 3, 4. We end the first row using a semicolon, and then proceed to type in any further rows. 5, 6, 7, 8, and maybe another, semicolon, 9, 10, 11, 12. Notice, as long as each row has the same length, we will have a proper rectangular matrix, and Matlab will be quite happy to produce that and save that in memory. Furthermore, if we want to, say, produce a longer matrix, something too big to type into one physical line on the screen, say because it's a super long matrix, or because our screen is particularly small, we can also do something like this. 1, 2, 3, 4, 5, 6. Oh no, that's too long. So I'll end my row with a comma here, but I'm not going to end the row. Instead, I'm going to go ... 3 dots, type enter, move on to the next physical line of my command window, and then finish typing my row 7, 8, 9. If I had another row I wanted to make on my matrix, I would have typed semicolon and continued along on that, perhaps with another ... But in this case, we've used the ... to produce one row of a matrix in 2 written lines, and that one row of the matrix is, of course, 1 to 9, all in one row, a nice row vector, if you will. If you want, instead of a row vector, say a column vector, in fact, let's name this one b equals, we can type the numbers for the column. And of course, since a column only has one entry in each row, we don't have any commas involved. We simply go 3, semicolon, 2, semicolon, 1. And we've produced ourselves a very nice column vector, semicolons indicating the end of each row once again. Now, although I've used commas, technically you don't need to use them. You can instead use a equals and use spaces. I know, why didn't I say that at first? Well, let's take a look. If I use spaces, say a is 2 space 4 space 0, still semicolon indicate the end of the rows. 5, -1, 2, and end the bracket to close the matrix. This will again produce a 2-row, 3-column matrix just like before. But notice, if you look up in the workspace there over on the left, we'll notice that it indicates still that the rows are separated, entries along the row, with commas. That's fine. I prefer putting commas when I type them in, but spaces work perfectly well. Clearly, the Matlab people prefer commas to indicate the spacing of their matrices too, but it doesn't really matter. Either works perfectly well. Now, commas and semicolons are not only used to type in the entries for matrices. They can also be used to expand, extend, and modify matrices. So, for instance, here I have my A matrix. What if I want to add another row to A? Well, then I'll say that A equals now the original A. And since I want to add another row, I'll type a semicolon, and then type in the additional row like usual. Say 0, comma, -2, comma, 1. As long as the width of that row matches the width of A, as long as the dimensions match, we've now added another row to the A matrix, 0, -2, 1, right across the bottom. I can similarly add on other entire matrices to A, merging them together, concatenating them, as long as the dimensions match. So for instance, I might make a new matrix M, which is going to be the matrix A, and we will attach along the side the column B. Since B is not attaching at the bottom, but attaching at the side, we are going to add a comma after A and extend this row by adding the new column B. So we have M is A concatenate with B together. This is exactly what you would see if you were working with a linear system trying to solve the system. You would take the coefficients together as a coefficient matrix, the constants as a column matrix, A for the coefficient, B typically for the constants, and then glue them together, concatenate into the augmented matrix, which in this case is our M. And of course, when you try to solve that system, typically you'd go through and put it now into reduced row echelon form. And while we're here, let's do that. There's a nice command for that. Surprise, surprise, it's RREF. RREF of M, of course, is the reduced row echelon form. And here, that form can read off the answer to solving the linear system. X equals negative 0.6 da da da, Y equals 1.07 and so forth, and Z is 3.14 and so forth. So that lets us solve the linear system just like we do it by hand by taking the coefficient matrix, the constant matrix, concatenate together, and then reduce. Once we have a matrix, of course, we can also pull out elements of a matrix and modify them individually. For instance, I might say M2, 3, which of course from our M matrix we see row 2, column 3 has entry 2. And I could change that to a new value by just typing M23 equals 42, say. And now the M matrix comes back with the row 2, column 3 entry replaced by 42. Notice that I can also generate matrices in other ways. Sometimes you just need a random matrix. Simply type rand 3, 4, and we produce a 3 by 4 matrix of random numbers, values between 0 and 1. If I need a square matrix of integers, people often like to use the magic command, which magically produces an integer matrix. But notice the matrix will always be square. It will always consist of integers from 1 to the size squared. So in this case, a 4 by 4 matrix from 1 to 16. And always, if possible, the rows and columns will add to the same value. Because of that, although it looks pretty, it's a little dangerous. Because often if we try to do things that require special properties or testing some feature, this particular matrix will have very specific properties. And so sometimes it's not general enough. If we want to be a little bit more general, but if we want to take with integers only, instead I'm going to use the rand_i operation. Rand_i 2, 3, 2, 6, say, would generate a matrix of random numbers whose integer values run from 2 to 6 inclusively. And then we type the dimensions, say 4, 3, to generate a 4 by 3 matrix whose numbers consist only of the integers 2, 3, 4, 5, and 6. And finally, when typing in matrices of integers, you very often don't want any old matrix, but you really want the identity matrix. How often, when working in algebra, do you use the identity? Well, there's a special command for that. Type I, and then the width of that matrix you want, say I4. And then you produce an n by n, in this case a 4 by 4 identity matrix, exactly as you need, with only a very little bit of typing. So keep your eye on that one. And that's it for this video. Remember, there are other videos in this series. Specifically, there's Making Matrices Part 2, as well the immediate sequel to this video, which really is Matrix Arithmetic, the Basics. So go take a look for those and other videos in this series on the website where you found this video. Good luck with your MATLAB.